Hey guys, we wanted to do just a very short video to make sure that you are comfortable with taking information in a data table about time and distance and turning that into a graph. You certainly might be asked to do that on an assessment. You also might be asked to go the opposite way. You could be given a graph and then be given a choice of data tables and asked which data table correctly goes with the motion graph that you're being shown. So right here is a data table. I have time in seconds, and then I have distance in meters. And the very first thing, let me go over here and grab this pen. Very first thing we want to remind you is since the time is listed first, we know that that is going to go on the x-axis. So I'll put a T for time over here. I already have the x-axis labeled. I notice that the seconds go from 0 and then just go in units of 1 each time. So 1, 2, 3, 4, 5 seconds. So we have units of 1 over here on the x-axis. The distance is in meters. It starts at 0, and then I notice it goes 20, 40, 40, 80, up to 120. So I just went ahead in my, when I was labeling the y-axis, I decided I would just go in units of 20. So here's 0, 20, 40, and I just went up to 120. And that's good enough for what we need to do right here. So this is my distance. Okay, so there we go. I have time on the x-axis and distance on the y-axis. Now this is just showing me that whatever object this is, it started right here at 0, 0, and then it went in motion. And after 1 second, it was 20 meters away from where it started. At 2 seconds, it was 40 meters away, and so on. So what I'll do is begin to plot these points over here on the graph. So I started at 0, 0, right there is that. At 1 second, it is 20 meters away. So I'll just come over to 1 second and I'll go up to 20. Here it is, 20 meters away. And boop, that's the best I can do. Put my little dot there. At 2 seconds, it is 40 meters away. Little dot right there. At 3 seconds, it is still 40 meters away. So I'm over to the 3, up to the 40. Oh, that's terrible. Let's try to make that. That's a little better. At 4 seconds, it's at 80 meters away. So here's 4. And I'll go up to the 80. And then finally at 5 seconds, it is 120 meters away. Now, the next part of this is that I want to be able to connect these dots. And so I'm just going to grab some lines here. And let's see, let's connect that one. That looks pretty good. And I'll go up here, right there. That looks pretty good to me. And I messed up there, but I'll do the best I can. Pretty good right there. It's not too bad. And then I'll go stretch that up there. And I need one more. Oh, look at that. Where did that come from? Okay, and then I'll stretch this on up to here. All right, and that looks okay to me for what I'm doing here. Now, this should make sense. All right, this is telling me that right here I have a nice straight sloped line. Remember, this does not mean that I'm going up a hill. This simply means that I'm going at a constant speed, moving away from where I started. Right here, when I see the horizontal line, I know that the object was not moving. So just right here, its distance did not change over that little period of time, so I know it wasn't moving. And then again, it begins to move again at a constant rate away from where it started. Remember that I could also compare how steep or how sloped these lines are. So for those of you who've already done some work with slope, you remember that slope is simply the change in y over the change in x. Well, y is distance, and x is time. So that should make sense to you. If speed is equal to distance over time, that simply means that the slope of this straight line does give me the speed of that particular object at as it goes over that particular period of time. So from here to here, for example, if I wanted to figure out the speed of that, I would just say from this point to this point, I would say speed is equal to distance over time. And I'm doing average speed, not instantaneous speed. So the total distance traveled from there to there, total distance traveled was 40 meters. And how long did it take from in this segment to go that 40 meters? It took 2 seconds. I can see that. It took 2 seconds. And at that point, 40 divided by 2 is 20. And so the speed from here to here is simply 20 meters per second. So that's just for this portion from here to here. Right here, I know that it's not moving. And then you notice from here to here, the slope of the line appears to be much steeper. So in other words, imagine that you are, trying to like go up a hill or whatever, and here we go, and that's a pretty hefty hill, but that's an even steeper line right there. So I would predict that the speed of this line should be more, it should be greater. The object was going faster from here to here than it was from here to here. Now remember, this does not actually mean going up a hill. It is reflecting moving away from where you started. However, I can see that this looks to be much steeper. So I'm going to calculate and see if I'm right. I'm going to do that. Let me see about the speed from here to here. Let's see if I'm right. Speed is equal to distance divided by time. I started at 40 and I went up to 120. I started at 40 and I went up to 120. So 20, 40, 60, 80. So I traveled 80 meters. Okay, traveled 80 meters. How long did it take me to travel that 80 meters? Well, that segment starts at 3 seconds and it ends at 5 seconds. So it took me 2 seconds to go from here to here. And 80 divided by 2 is 40 meters per second. So that matches. Everything looks good to me. I can calculate the average speed from here to here. I know the object was not moving right here. I can calculate the average speed from here to here. This is a much steeper looking line, so I know that the object should have been going faster here than it was here, and it was. It was going 40 meters per second right there, and it was only going 20 meters per second right there. And so that's how you take a data table and make it into a graph.